Hello, I'm Jesse with American Radon. Today we're working on a big house out in Stillwater, and it's about 90 feet long and about 35 feet wide. It does not have drain tile, so it poses some pretty significant challenges as far as radon mitigation goes. So typically the key to getting your radon levels really low is to get vacuum or suction on the entire home. Let's take a look and see how we do that. So with radon mitigation, the idea is to create suction under the home, so we want to seal up any openings or gaps to the soil. So a lot of times with the bathtub or the shower in the basement, there's what's called a plumbing blockout. So it's like a 1 foot by 1 foot hole that's open to the soil. So a good way to seal that is going to be with an expanding foam. So you can use stuff like this. These are a little bit more maneuverable. And then if it's a shower pan and it's hard to reach, you can use the 4-foot foam gun. You want to be careful that you don't shoot too much foam in there, or you can actually lift the tub up as it expands. So the window and door foam works good for that stuff. The reason we seal holes and openings to the soil like this is because it allows us to install a better, more effective and efficient radon mitigation system. So here we've got one of our diagnostic test holes. We've got about 10 of them in this house so far, and this allows us to measure the suction that we're creating in each area of the home. And again, the key to getting your radon levels low is to get vacuum under the whole house. So all these tubes will get sealed into the floor here, that cork, and they'll all run back to our micromanometers where we measure. So now that we've got all of our test holes done, we want to find out where we're going to suck from. So we've got a couple different options on this house. So we've got our 1.5-inch test hole. That's where we're going to suck from. We're going to tape this hood down over the floor there. And then we've got a 3/4-inch hole there that we'll use in a second as well. So we're going to hook this pitot tube up so we can measure the airflow. Hook the shop vac up to the pitot tube. With this valve, we can manipulate that shop vac to increase or decrease the amount it sucks. And then we're going to hook our micromanometer up to that test hole as well. So when we turn on the shop vac, it's going to tell us how much air we're moving through this pitot tube and at what pressure. And then that will tell us if we're reaching all of our test holes. So now we've got our shop vac on, our valve is open. This reading tells me that we're moving about 35 CFM. Our next step is to measure our pressure field extension of our 10 test holes. So now we've got one of our 10 test holes. We can see that it draws the smoke down. Otherwise, we can use our micromanometer. We can plug that in. We're going to see that we get about 85 pascals negative. In a perfect world, we'd like to design a system that gets 5 pascals negative on an entire house. So we've checked one of our 10 test holes. We know we're good here, but some of the other ones we may still be positive. If after we put in our suction point and we're still not reaching everything, we may have to introduce what's called stitching, and we'll get more into that later. So we've looked at 2 different suction point locations. Based on the numbers I'm seeing, this is going to be the best location to suck from. Our next step is to core the 5-inch hole through the floor. So now we've got our 5-inch hole cored through the floor. Our next step is to excavate the suction point. Probably going to take about 40 gallons of material out of there, and then we're going to run that pitot tube test again and see what it does for our pressure field extension numbers. So with our one suction point, we found we weren't getting the pressure field extension we wanted. So we're going to implement a process called stitching here. So we've got a series of 5-inch holes, cored every 2 or 3 feet, and then we auger and vacuum the sand out underneath and create a trench under the floor here. Then we'll put these plugs in, fill that with concrete, and then when they put the carpet back, you'll never know it was there. I'm happy with the numbers we have on this side of the house. But down on that side, there's a bedroom that we're not really reaching. So we're going to do a little bit more stitching down there, and we should have the desired pressure field extension that we want. In a house with an unfinished basement, we could have simply just dropped in an additional suction point to get the pressure field extension we wanted over there. But in this house, we've got the finished ceiling, finished basement, and dropping the ceiling here wasn't really a good option, so that's why we're doing the stitching. So now we're on the north side of the house. We don't quite have the pressure field extension that we're looking for, which you can see from the micromanometers here. And we've got to add another suction point to create the suction that we need down here. So we've got a bathtub there that you can see, and we can use that to our advantage. And the reason why is when they laid the pipe, they dug a trench, laid that pipe in the floor, and then kicked the soil back over. And a lot of times that settled a little bit, so we got a little air gap between the soil and the bottom of the concrete that we can use to our advantage to draw air through. So before I sealed that bathtub hole up, I created a suction point out of that. I filled it with rock, and then I foamed at the top of it to make the seal. Here I cored a hole through the floor, and we've got our pitot tube hooked up to that so we can simulate the suction that the radon system is going to create. So we don't quite have the numbers that we want here now. So now when we open this valve, we simulate the radon system creating the draw that it's going to create. So we're good on all the numbers here except for this red tube which runs back to the corner of the bedroom. And the reason that we don't have the numbers we're looking for there is it's right next to some cracks that have not been sealed. So once we seal those, we should have the numbers that we need. So with stitching, we're going to core a hole every 2 to 3 feet, depending on the soil conditions. And then we're going to use this auger on the drill to loosen up the sand, and then we can suck that out with the shop vac. So once we get all of our stitching complete, we're going to take these styrofoam plugs, which I've cut out of styrofoam with a hole saw. We're going to press this down in the hole and seal it. We're going to take a long tap con so that the concrete plug has some support and screw it into here, and then we'll fill the rest of that hole with concrete. So when they put the carpet back, you won't see any of these holes. And that's the process of stitching, and it's very useful when you cannot run pipe in a finished basement. So in some larger projects that last several days, we like to run a temporary system. So we've got our flex duct hooked up to one of our suction points. It runs out the window, it's hooked up to a radon fan, and then we can see what the radon levels do while we're working on the project and overnight. So we've got a radon test set up on this side of the house and one on the bedroom on the other side of the house. So we look at that report, and we're around 5 when I started the radon test, when we started the project. And then while we worked the first day, you can see the radon levels came down. Overnight, when the house was closed up, we weren't sucking on anything, the radon levels rose back up to around 5 and 6. And then yesterday while working, we installed this temporary system, and then overnight you can see it consistently kept the radon levels down. We're hovering right around 0.6 on both of the tests right now. And this helps us confirm that the system that we design and engineer is going to work. When running the vent pipe, we've got to secure that every 8 feet vertically and every 6 feet horizontally, and we've got to pitch it properly. So to secure it, we use U-straps, J-hooks, and pipe hangers. So we're in the storage room now. This is where our 2 suction points come together. So we've got all those holes stitched. Our suction point is that void under the floor where the radon fan will draw all the radon gas up into the vent pipe. And finally, we installed our manometer, which is a visual gauge to tell you the radon system is working. That little tube runs into the pipe, and when the radon fan is sucking, it draws that fluid up. And then we've got our airflow alarm, which is a gauge that has a flap that goes into the pipe. When there's airflow, it lifts that flap up. When there's no airflow, it falls, and it will alert you within 30 seconds if there's a failure with your radon fan. And then these two suction points run out to the garage. And then one other thing we have here is we've got the dampers so we can control the flow. So if I need to suck harder on the south side of the house, I can do that by closing the damper down a little bit on the north side, or vice versa. So we've got our pipe stubbed out to the garage here, and when we go through the garage, we are going through a fire-rated wall. So to maintain the integrity of this wall, we need what's called a Firestop collar. So how this works is it mounts around the pipe, and if there's a fire in the garage, this pipe is going to melt away, and this intumescent material right here is going to expand up to 60 times when it's heated, and it's going to close off this opening to protect your home from the fire. So we need it down here, and then we'll need one on the ceiling because that's also a fire-rated wall. So we've got our 4.5-inch pipe coming out. We cut a 5-inch hole to allow for our smoke sealant. So rather than fill that whole void with the smoke sealant, we've got this backer rod, and it's pushed in just beyond the sheetrock. So we want the smoke sealant to cover the back of the sheetrock out. So now we're getting ready to put the Firestop collar on. So that just slides over the pipe. So since we're securing to wood, we're going to use number 8 steel wood screws with a 1-inch fender washer. On the ceiling, we'll be just securing to the sheetrock, and we want to use 1/8-inch toggle bolts for that. And this is a step we often see missed by many contractors. This goes on the pipe like this. It does not go over it does not wrap around the edge of the foot fitting like this. So make sure that if you're hiring somebody that they do it this way. So we're finished up in the garage here. We've got our vent pipe running all the way up into the attic. We've got it wrapped in insulation. The reason we do that is it prevents condensation from dripping on the sheetrock and makes it a little bit less likely to freeze, and then it's a little bit quieter as well. And we also got our Firestop collars, and that's about it for the garage. So now we're up in the attic. Our vent pipe continues from the garage up to here. We've got it going up through the roof here. We've got our radon fan that's going to create our suction. Our vent pipe is insulated. We already talked about why. On this fan, it's pretty noisy, so we've got a noise suppressor under here, which is going to cut the noise by about 75%. This is an adjustable speed fan, so we can dial that power up or down based on our needs once we finish up our ceiling and get everything balanced in the basement. The only thing we have left up here in the attic is to get the electrician here to wire an outlet within 6 feet of the fan. We just ran the vent stack out through the roof, and there's a few things we got to take into consideration because of the radon code. So we got to have that exhaust point at least 10 feet off the ground, a foot above the roof, and then any window within 10 feet, we've got to be 2 feet above that so it doesn't get back into the house. We've got a Criticard cap that's going to keep birds and squirrels from getting down in that radon fan or acorns. And then another thing that we do is we paint that vent pipe a dark color to match the shingles, and then it's also going to have help the sun keep it a little bit warmer and less likely to freeze. So an important aspect of radon mitigation is sealing, and we do that because we want to increase our pressure field extension, so how far our radon system reaches. Again, the key to getting your levels low is to get vacuum under the entire house, and then it also limits loss of conditioned air, so air that you're paying to heat and cool isn't being drawn into the radon system and thrown outside. So what we use to do that is we use this expanding foam. This allows us to get in to the little areas like under the trim and sheetrock to seal the stuff that we can't get at very easily. And then for the control joints and the cracks and gaps in the floor, we're going to use this radon sealant. So it's a green, low VOC product. We don't want to use polyurethane because it's going to be bad for the family living in this house. And in this house, we had a great opportunity because the carpet was all going to get replaced. So the owner ripped it out and we can seal up just about everything except for that bedroom down on the other end. So here we're on the walkout side of the house. We've got this floor to wall joint that we have an opportunity to seal and make the system more efficient. So here we're down to our last portion of control joint, and as we seal that, you'll be able to see and hear the difference that it makes as we seal that up. So now we'll wipe and smooth this out, and our next step is going to be to check our pressure field extension and balance our system. So to wrap up, we've got our radon fan dialed in to what we want it set at. Our dampers are adjusted. We've got negative pressure or vacuum under the entire house. You can see we've got 80, 78, 42, and 19 pascals negative. So we're reaching everything. That was our goal. And finally, we'll do our post-mitigation radon test to see how well our radon system's working. I'm Jesse with American Radon Mitigation. Thanks for watching.